In this video, we're going to look at Kotlin native multiplatform and to see what the possibilities are to have a shared code base to be used for both iOS and Android. This draws a little bit from the example and the tutorial that's available on the Kotlin site. And I have a prepared project that I'm gonna go through just to show what is possible. So it is based around a new project in Android Studio with some added things for Kotlin multiplatform. If we look at the structure here, we can see that this is basically an ordinary Android project. And then we have a part here that is the shared code. And what we can see here is on the source we have an Android part, a common part, and an iOS part. We have a build Gradle file here that sets up how this works. We're going to come back to this soon. Just gonna see it run first and then look at how it's structured. The thing is, here we have in the common, I have a common Kotlin file. And here I based this around their example, which they have here, code for a platform name with a function just says create application screen message, which should give a string. The thing is, this is common code that is run, but the thing is, it should return Kotlin runs on platform name. Platform name is this function up here, which does nothing. What it does is that it expects something to be defined for both Android and iOS. So if we go to Android here, in the Android part we have this is expect platform name, and here in this code we have the actual function for platform name, which just returns Android. And if we go down here to iOS, we have here the actual platform name. And what it does here in the iOS, it draws from iOS specific things such as UI device, get the device system name, and system version. Just to show that we can do some code for Android, some code for iOS. The thing is, this generates the shared code. So if we look at the Android code here in the main activity, the commented out parts we're gonna come to in a little while. Here, I just did like this. This layout is very simple. I have two text views that I'm going to use in this example. So what it does is, it says here, run the function create application screen message, which is defined down here in the common code. Create application screen message, which uses platform specific code. So it just put this in one of the text views, the other text views is left blank. If we run this in the emulator, we get this. Kotlin runs on Android, which is great. Then I have an iOS project which is said to use here, to use our shared code framework with a layout which are 2 UI labels for iOS, and the code is import shared code, and here set the label to from the common Kotlin file, create application screen message, and empty the other one. So I have a layout defined for Android and a layout defined for iOS. And if I run this in the simulator for iOS, I get Kotlin runs on iOS 12.4 in this simulator. And this it got from the platform specific code. If I were to change this and say that in the common code here, it should say Kotlin runs on *** platform name ***. Instead, run on the emulator. I get Kotlin runs on *** Android ***. If I go to Xcode and say just run, no changing code. The thing is, this takes a little while because it actually builds the framework behind the scenes. So this takes a little while. While it does that, we can check up here in the settings here. Oh, it's launching. Kotlin runs on *** iOS 12.4 ***. So I changed it in one place and it changed on iOS and Android. Here I have, as they go through in the tutorial, in my target, I have here in the build phase a script that says run here Gradle code pack4 Xcode, which is defined here in the project. Here is a script for pack4 Xcode, which does the framework configuration thing. So as I change the common code, I can just hit run in Xcode and it will build the framework behind the scenes. So this is great. I can make a function, like in this case, that just returned a string and have that show up in the different ones. I could have some kind of function that does some calculation or something like that and some business logic and things like that, and have that here in the common code and just be called from Android and called from iOS. So shared code. We're gonna take this one step further. We're gonna look here now to add some network capability to make a very simple API call. To use this, we're going to add Ktor, the Ktor client. And this enables us to have all the network capabilities here in the common space. So what we're going to do now is Ktor is added here. And it's added here in the Gradle file for iOS Ktor and the Android and the common. What it looks like in actual code is here in the common code, and actually almost only in common code. I've added a thing here. I have a simple class, do API. We're gonna do a very simple call. What we're gonna do is we're gonna get this file, title banana amount 42. Very simple JSON file. So the common code here is ktor, give me an HTTP client. I have a defined function, make call. This has a which URL are we gonna call, and a callback. We're gonna return a string. So this is a callback to be returned. So if someone calls make call, go to a URL and returns the content as a string. The actual code here, it uses coroutines to actually launch this and say client get that URL. And this takes time and freezes this thread, this coroutine. And when it's done, it calls the callback with the result, which is a string. The thing is, this uses an application dispatcher, which we can see up here. Expect application dispatcher. Expect, like we did with our here platform name, expect, which means that we have an Android implementation and an iOS implementation. We're not going to dive too much into this, but this is to be able to run the coroutine for Android. Here we have the actual application dispatcher. It just says dispatcher default. That's the simple one. In iOS, the actual application dispatcher uses an NSQ dispatcher and handles that. So they are actually implemented differently, but this is basically done once. Then in the common code we can use here, we have a function. We point it at a URL, we get a string back. Check. Now we have this function here, get dummy. The thing is, here we're gonna get our JSON object, which has a title and an amount, banana 42. So I say here, make the call to my Dropbox link. I lazily put a file in Dropbox to be downloaded instead of building an actual API service to be called. So I say, make the call for this URL, which should return a string in the callback. So here the callback, it is a string. Right, so now we have a string. And actually what we can do now is here in the common code, I have a model for a dummy thing. And here I use the Kotlin serialization and say this is a serializable object, a dummy thing, which contains a title, which is a string, and an amount, which is an integer. So I define my models also here in the common code. So it's done once. So here in the common code, I say make the call, make the API call. And here I say the JSON parse it, which is the string we got from the URL, and say this, try to serialize it as a dummy thing. So then we get back here, this JSON data is a dummy thing. So now we actually have here in common code to make network request from a URL, get back a string, try to JSON serialize it into our own kind of object. So this is all the common code, and this could be get a list of products or save an object to the server or any kind of thing. We don't, apart from the coroutine dispatcher here, there's no separate code for iOS or Android. This is the make call to the API. So let's implement this in Android. Here I had the code for Kotlin runs on. So let's comment that out. And let's take this in. And here my code is, let's do a do API class object, like we had here. Do API, and then we're gonna call the get dummy. So give me do API, an API get dummy, which returns in the callback, it is a dummy thing. And as we get this back, we get this in a background thread. So we're gonna place this in our text view on the screen, which means we have to run it on the main thread. So here I say, launch this on the main and say, the one text view, set the title of the object, one, set the amount. So you could say that this is the platform specific part for Android. So as I run this, I get banana 42. The iOS part for this, if I look at the code and I say the same thing here, comment out what we had before, and instead do like this. And here I have do the do API, create an object, and do the get dummy, and I get back a result. And this result is a dummy thing object defined in the common models. And again, run this on the main thread because we're going to paint the UI. I say one labels text comes set from the title, and the other one take the amount. And it says here int value, because the amount I get here is actually a Kotlin int. So I have to say, give me int value. So as I run this, I get banana 42 in the iOS code. So if I want to add something more to this, let's say I want to add something to my model, to the dummy thing. I would like to a demo, I would like to add a function that does, let's say, a function that is the pretty title, something like this, which should return a string. And we say, let's return star star plus the title plus star star, something like this. Yay, we want the pretty title instead. So we define this in the common code like this. And if I want the pretty title instead, I do in the Android code and say, here, take the title. Now I would like it to do the, we should run this just to have it built out so it can autocomplete. So let's say I want the pretty title. You can run the Gradle task here to have it run instead. But now I have star star banana. So I have the code for that. And let's say next code I would like, instead of title, let's do the same thing here. Let's build it out so we have the, we can let it autocomplete for us. And let's so now it's actually building up the framework using Gradle in the background, and when that's done it launches in the simulator. It's just this normal title. We get the normal title, but now instead we want the pretty title. So we get star star banana star star. If you do this correctly, you should move as much code as possible to the common part. As you do in a good code structure anyway, you try to have the view controller, the activity code, the fragment code in Android to be as stupid as possible. You want to move all the logic to a kind of view model kind of thing. You should think the same way here. So have stupid code here that just says, hey common code, what should I display? So that should be simplified. What you don't want is start building in the same thing in both iOS and Android. So you should do something like try to get this dummy, and if there were something like if the amount is 0, we should display something, then that code should be in the common. So then perhaps we should have a display message defined in the common code which does the logic that if amount missing, return the missing code, the missing text message. So this is an overview of how this works, and there are many more parts of this, and this can be built out with many more things. I have a beginning to add here, which is the common part, coming part with the SQL Delight, part, which is the possibility to have a common SQLite database in the common code. So that's a coming part. Let me know if there is anything else you would like to see in a coming video. I plan to do a few more videos doing Kotlin stuff and building on and building more advanced Kotlin native multi-platform projects. So if you want to see those, please subscribe to this channel and be notified when videos come.